Welcome, everybody. There we go. The actual recording. Um, Welcome to part two of our Ontario Embodied Carbon Awards Winners Series. And today we're going to hear from the winners in the categories for new construction, small buildings, innovation in industry, and interiors. Just going to minimize something that's in my way here. Just a little bit as a reminder about Carbon Leadership Forum. Um, our mandate is to inspire and spur collective action to solve the embodied carbon challenge. Um, as the Toronto-based group, we acknowledge the land we are meeting on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse nations, Inuit and Métis peoples. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. Some housekeeping items. Feel free to put questions in the Zoom chat. We'll probably keep them to the end, and it can be for any of the presenters. You can ask questions. We recommend you use the speaker view, and I would turn your audio and video off, just so we don't have any lag. And then, as you might have heard, our session is being recorded. So again, we're going to hear from Deirdre with Strawworks for the winner in the new construction small buildings. And we're going to hear from Melinda and Rick from Tooktree for the innovation in industry, the winners in that category. And then BDP Quadrangle Interiors, we're going to hear from Jessica on that one. So with that, I'm going to hand it over to Deirdre, who's going to take the screen and tell us all about why they're Project One and some of the work that they're doing.
Thanks, Heather. Yeah, hi everybody. My name is Deirdre. I'm a designer and builder. I started Strawworks 21 years ago and I still love it. We are based in Peterborough and we build 1 to 2 straw bale buildings a year. And we're thrilled, by the way, to have won the 2024 Carbon Leadership Forum Embodied Award for small buildings. I'm actually sitting in the health center. I've got the award here. So I'm going to share my screen now. There we go. So this is the Strawworks homepage where you can find more information about us and links to our social media feeds. Strawworks is a natural building company working on climate change one building at a time. One building at a time by choosing more plant-based materials that store atmospheric carbon and fewer materials with high carbon emissions. We are committed to being more part of the solution and less part of the problem. The baseline that we compare all our projects to is net zero embodied carbon or better, and we're getting there. So as Heather said, today we're going to take a close look at this project and really look at the three main things that added up to a win. Just before we do that, I want to give a big shout out to the people at, excuse me, Builders for Climate Action and BEAM, their building emissions accounting tool. We couldn't do what we do without BEAM. We use it all the time and donate monthly. For the last few years, we've actually included the carbon emissions in our quotations right next to the dollar price and present lower carbon footprint options to our clients. So we designed and built the Rotary Health Center at Camp Kawartha we designed the Rotary Health Center at Camp Kawartha in 2021. Camp Kawartha is a summer camp for kids and a year-round outdoor education center. It was celebrating its 100th year in 2021, and building the health center was its centennial project. So it replaced sort of a dilapidated nurse's cabin built in the 50s. quick walk around. So I'm actually sitting right here. This is the entrance to the health center where kids would come in if they need a Band-Aid or something bigger than that. Then they'd go into the exam room where they would see a nurse. There's two sick rooms if they need to stay overnight. And then there's a nurse's quarters at one end of the building. So this is the living room. And here's how this project looks in Beam. If you take all the emissions minus the carbon storage, then the final score is 6,554 kilograms of CO2e, and that breaks down to 32 kilograms per square meter. So, how did we do this? Well, geometry plays a big part. We're going to look at that. And then also, really just every step of the way using materials with low carbon emissions and using as many carbon storing materials as possible to offset the emissions, which inevitably add up. This was bring your kids to work day, so I had to find a way to work that slide in. So if we're looking at the geometry here, the old construction adage that it's cheaper to go up than out is also true for embodied carbon. So foundations and roofs generally have high carbon emissions associated with them, whereas I see walls, floors, and roofs as empty cavities that we can fill with carbon storing materials. So if we had taken the same footprint of this building and spread it out, like say into a long bungalow over a full basement or even a concrete slab with a full roof, of course, then the carbon emissions would have gone up. So what you're looking at here is a partial walkout basement, so just under half of the building. The back two walls that are backing into the hill are Nexem, and then as soon as we could, we switched to carbon storing straw bale walls in the walkout basement, and then straw bale walls above, floors filled with dense packed cellulose, cathedral ceilings filled with dense packed cellulose. So right off the hop, at the foundation stage, the building sits on a 2 foot by 5 foot bed of compacted stone instead of a conventional concrete frost wall that drains to daylight. By choosing concrete with the same strength but a 50% SCM content, we decarbonize the concrete fill in the NextM foundation walls by approximately 30% in just one phone call to our local concrete supplier. It's by far the easiest concrete or embodied carbon reduction that we can make. And then we used leftover Nexem blocks from another project for the two below grade walls, as I said before, switching back to carbon storing straw bale walls for the above grade walkout walls. Nexem is an insulated concrete form made of wood chips in cement from 75% recycled wood material. It's made here in Ontario. These are the straw bale walkout walls on top of two courses of Nexem block. We unearthed these major boulders during the excavation and felt like we had to use them. And we also took down some poplar trees. So in one quick phone call to the engineer, we were able to swap out concrete piers for big boulders, again, sitting on a rubble trench foundation, and poplar posts right from the site instead of cedar posts. So I like to tell kids this story because the trees came down and then they literally went back up in the same location. Uh, Wood framing for the walls and the roof, again, low emission. Get the roof on, and then the biggest climate hero on the job site is also our signature work. Tightly fit between a double row of studs. The 300 bales are storing just over 5,400 kilograms of carbon. They're also locally sourced, highly regenerative, non-toxic, and offer excellent thermal performance. We'd definitely be a carbon sink if we just filled the building entirely with bales of straw, but we do just put them in the exterior walls. This is what that looks like, giving them a haircut. Lots of prep work to ready the bale walls for plaster. The early straw bale houses in Ontario were plastered with cement, lime, and sand, and we haven't used cement in our plaster since 2009. Clay and lime offer better performance, less maintenance, and lower carbon emissions. So the runner-up to straw bale walls is definitely dense packed cellulose. The cathedral ceilings, the wood frame floors, and some interior walls are all insulated with carbon storing dense packed cellulose. And it all adds up to an impressive 6,538 kilograms. So we insulated the interior walls mostly for soundproofing with hemp bat. Um, Maybe I can throw this out there. This is a test or a question for the group. Is hemp bat a carbon storing material, or is it a low emissions material? We can come back to that. Something else that we do is slabless slabs. So instead of calling the concrete truck back to pour a slab in the basement, we compacted a 5-inch base of limestone screenings over gravel insulation and topped it with a 3/4 inch earthen floor. We use cement, but sparingly and mostly for below grade and structural applications. So the basement floor of the health center is insulated with two different types of recycled glass, Glavel, which is out of Vermont, and Pour-Raver, which comes from Ontario. Both are made by heating and expanding glass into insulation suitable for below grade applications. So our earthen floors are glossy, water resistant, and hard like polished concrete floors, except the binder is clay instead of cement. On this project, we installed 173 square meters of earthen floors, so earthen floors everywhere. on the main floor and in the basement. And at just 3/4 of an inch, this innovation is more in spirit than in drawdown reality like straw bale walls, except that there is chopped straw in them that we use as fiber. And these floors allow us to deliver the slabless slabs, which offer significant carbon reductions by avoiding cement. So those two innovations work together. Honorable mention to carbon neutral lime paint and green roofs. So the health center's operating emissions are also low thanks to the climate-friendly Sandin high-efficiency air-sourced heat pump. The Sandin uses CO2, a benign refrigerant, compared to the highly potent hydrofluorocarbons in most heat pumps. And for the last 4 winters, it has solely heated all the domestic hot water and the health center hydronically through the earthen floors. And it's all powered by Peterborough's relatively clean grid, which is 71% hydro, 28% solar, and 1% biogas. So what's new and exciting? Well, I'm working today. We're building a sleep cabin right next to the health center at Camp Kawartha. And we're pretty pumped that we just insulated the cathedral ceiling with dense pack chopped straw. So straw stores more carbon than any other insulation material. So the 4,000 pounds of finely chopped straw that we dense packed into the ceiling is storing approximately 2,700 kilograms according to Beam, and that's 1,700 kilograms more than if we'd used dense packed cellulose, which is what we have been doing. We just hand packed as we worked our way up the roof, and then blew chopped straw to fill at the peak, blew it through our dense pack cellulose machine. So the chopped straw R53 plus the Gutex R11 for a combined R value of R64. So lastly, I just wanted to say thank you to our partners, Camp Kawartha. They're amazing clients. And also thank you to the Carbon Leadership Forum. It really means a lot to me to have won this award. It makes all the hard work worthwhile. And in posting and telling people about the award, it was also an opportunity to just tell the story and talk more about what we do. So I think they're really important. I think healthy competition is good. So thank you, CLF, and thank you to Heather and Anya for organizing this event.
Thank you, Deirdre. Really great to see the project and learn more about how you achieved it. So appreciate that. Now we're going to pass it on to Melinda and Rick with Tooktree for their seed building systems and winning the Innovation in Industry category.
Okay, thank you. Let me see. I can just share my screen. Okay. Are you seeing my presentation now? Okay,
Yep.
fantastic. So yeah, thank you very much for the opportunity to be here and to be part of this webinar and part of the Carbon Leadership Forum, and fantastic to be among such fantastic colleagues and people working to make buildings better. And of course, that's why we are here as well, to address not just one piece of the puzzle, but seeing everything that we work on as integrated in terms of the climate crisis, the housing affordability crisis, waste management, the need for good, safe jobs, healthy communities, and of course, the right to safe, quality, healthy, affordable home for everyone. And so part of what we've been motivated by is the acknowledgement of and understanding of the um, need to address the carbon emissions of buildings. And so when designing the panel, and we again also shout out to the folks at Builders for Climate Action, and also RMI and Chris Megwood there helped significantly with the design and of our wall assembly, as well as just the work we've been doing in that sector, and all of our colleagues. I had been working as a general contractor for a long time and was looking to see how we could accelerate some of the carbon reduction improvements into people's homes and into the buildings we were building, and also move some of our work offsite for health and safety of our workers and the quality of the builds, and not have to mitigate some of the exposure to the weather and other things about the elements as well. So we moved to prefabricated buildings. At least the wall, floor, and roof panels. We generally don't do volumetric. We focus on the panelization and ship panels to our sites. And a recent building that we built was a duplex, a 2-unit home, and that stored 5 tons of carbon, according to our beam work that was done in combination in collaboration with Builders for Climate Action and RMI. And I guess I didn't really introduce myself properly at the beginning. I'm Melinda Zatarek, and Rick is my father, who is also here. And we've been doing this business together since about 2018, and started manufacturing in 2019. But we've been collaborating in the construction sector for quite a while before that. I've been in the construction sector for about 20 years, and was in the renewable energy sector before that. One of the key motivators for us, as I said previously, was good jobs and moving the sector forward. So our team is a core for why we do what we do, and how we do it, and key part of our success. Most of our team members have stuck with us for since they've come on board. And you see here, we also try to do advocacy whenever we can. They are all wearing emissions caps, which is part of a campaign that was brought to the COP meetings recently. So proudly wearing their accomplishments on their hats. And Rick, just to make sure, do you want to say anything about what we've gotten through today so far?
You're covering everything. I'm really excited to be in this business, grateful for the support we've had from the other builders, collaboration with folks like Deirdre, and for sure Chris Magwood, key to us getting along the way here. So shout out to Chris. The builders in this industry tend to be less competitive and more collaborative than typical builders, and we really like that. The team here is an awesome team. They're all committed to doing our mission. They've bought into our sales pitch. So go ahead, back to you.
Okay. Just a closer look at our panel. So we have a wood frame structural interior panel, and then a air barrier with a high performance membrane, and then the sheathing plywood, followed by a cavity of dense pack cellulose and then a lighter framed wall on the exterior, gusseted with the plywood casing to support the exterior siding and the insulation cavity. And there's wood fiberboard on the exterior of that, which we currently get from Quebec. When we started, we were getting it from Europe, but as now we're getting it from Quebec and hoping for more manufacturing of wood fiberboard in Canada and Ontario would be fantastic. And then another our weather resistant barrier on the exterior, followed by strapping that we customize depending on the direction of the siding that the project calls for. And so we generally work closely with the design team for a project. We have done our own builds in the past, but now we're focused on supplying panels to builders and developers. And we come into projects as early as possible from our perspective and for the benefit of the project. The earlier, the better, so that we can work with the design and to maximize the efficiency of our panels and help make the design as economical as possible, and also work with their timing. And so we generally are building our panels while our clients are building, doing their site work and doing their foundation, so that we show up and put the envelope up, depending on the size of the building, anywhere from half a day to a week, as soon as the foundation is in. Or we also do floor and roof panels. If we're doing floor panels, usually the foundation is a helical pile foundation. And then that interior structural cavity is ready for the rough-ins of the electrician, plumber, MEP, and we can go to site and help install the panels, but generally these days when the general contractors receive the instructions and training, they're quite prepared to work with the crane operator and assemble the panels on site themselves. They have the expertise to do that and to ensure the airtightness of the envelope. So our vision of a sustainable building is as affordable as possible to build, buy, and operate. So we look at the total cost of building ownership and working to help shift the way that building financing is done as well. Of course, energy efficient. Most of our partners are striving for net zero or net zero ready and all electric usage for lower carbon. Of course, making sure that we're mitigating and adapting to climate change as much as possible. And our primary clients, our top tier preferred clients, are not-for-profit affordable housing developers, multi-unit developers, folks that are prioritizing local community as well, and it's our value aligned. So we consider, as I started off with the presentation, that all of our values and objectives are really interconnected and are all equally important and stack with each other and help us be better at meeting the intent of all of our values. So how we run the company, who we hire, how we work together, what we pay folks, what the culture is, who we work with as clients, all of these things are key, and as is what we do with our approach to intellectual property. So we have, rather than try to patent or own the design or prevent others from doing similar work, we have licensed our panels under Creative Commons so that others, if they choose to emulate or use parts of what we've developed, they can do so as long as they share that openly as well and share any improvements that they make upon it with everybody, back with ourselves and publicly. So thank you again to the Carbon Leadership Forum. This is such a great opportunity to celebrate the achievements that we're all making in the sector and create the conversation about embodied carbon and keep that that important goal out there and provide more opportunities for us to not just celebrate, but to have that healthy competition and to talk to each other and share what we're all doing and help each other do better. So thank you very much.
Can I just add to that?
Mhm.
This is a more representative picture, a more current picture when everybody could actually be there. This is the team that does the fabrication, except for me in the red vest. Everybody else is on the floor every day, and we're proud to keep that little trophy in the corner there on the sample wall as well. So thank you again very much. We really appreciate it.
Yeah, thank you, Melissa or Melinda and Rick. Also great to see. I have a question, but I'm going to save it for after.
Okay.
We're going to pass it on now to Jessica with BDP Quadrangle, who won the interiors in the interiors category. Take it away, Jessica.
Great, thanks so much. Everyone can see full screen?
Yep.
Yes.
Great. Hello from BDP. I'm Jessica Goldberg, a senior interior designer at BDP, and I'm honored to present a snippet of our studio sustainability research and our awarded interiors project. And there's lots to talk about. A little bit about our studio. We have studios in 19 studios around the world and projects in more than 45 countries. We design for every part of life, from education to multi-residential towers, from media to workplace. Our global mandate is we design a world that's built for good. We have issued our first complete ESG report this year, which is very exciting. This document is about measuring how we're doing year over year and being transparent about our progress. At our Toronto studio, we've created a roadmap to get to 46.2 reduction in scope 1, 2, and 3 emissions by 2030. And in 2024, we have achieved this and a remarkable 100% reduction for scope 1. We take a lot of pride in the work that we do and the projects that we dedicate ourselves to. And we're focusing our efforts in these projects to raise the bar on sustainability achievements. As we can see here, our project roadmap reflects sustainable market shifts, starting on the left with LEED and transitioning to net zero carbon on the right. And at the transition of these market shifts, we're releasing research that aids in the collective sustainability knowledge. As we focus our attention on the drive for net zero carbon, this timeline shows the pathway, indicating the percentage of projects that we are targeting to meet these operational and embodied carbon targets each year. You will note that this is not projected to be linear, but exponential until all buildings are net zero. Which leads us to our research, in which we are seeking to raise the bar. Low carbon now is one of our major starting points for researching embodied carbon and discussing some pivotal moves to get high impacts now. Low carbon now transitioned into industry collaborations and the formation of a think tank of leaders coming together for an integrated discussion about accelerating the path to net zero. Finding ways to decrease carbon trajectory is key. That the time to act now is now, and that the decisions we make today will impact the carbon trajectory of a building for its lifetime. The whole life carbon footprint is a way to assess the operational and embodied carbon simultaneously. It runs from cradle to grave, that is, from product material extraction to ultimate building demolition, or better still, deconstruction, giving us a good indication of the carbon impact of a building's lifetime. If we take the Toronto metrics and map them over a 60-year service life, we see that the whole life carbon of a building operating under today's requirements is still dominated by operational carbon. The band at the bottom represents the upfront embodied carbon only at this time, and depending on the life cycle of material used, this value would increase due to maintenance, repair, and replacement. As we move into 2026 performance standards, we see the operational carbon target coming down, as well as the new embodied carbon targets coming into play. By the time we get to 2030 targets, the embodied carbon target drops again, and we see the impact of operational embodied carbon equalizing. And moving into a net zero ready building, we see the tipping point where embodied carbon now overtakes operational carbon in terms of whole life carbon impact. As the performance improves, embodied carbon becomes the driver. Our latest research about embodied carbon in design highlights the importance of early design decisions from envelope expression, design form, and material selection, and that those choices can impact embodied carbon intensity. But today we're here to celebrate the design and sustainability story of our Toronto studio. This project was very much an all hands on deck and an experiment on how to successfully tell the story of our dedication to not only a beautifully designed workspace, but one that has a sustainability story to back it up. We are so honored to have been awarded the Ontario Embodied Carbon Award for Interiors. Globally, the building sector accounts for approximately half of all carbon emissions, of which 28% is from building operations and 21% from new construction. For new construction, the focus has almost exclusively been on core and shell, the envelope, the structure, and central systems. Now data is showing that carbon emissions from new construction of interiors can be much greater when properly considered over the full life of a building. This project came about when we became the North American headquarters to BDP in 2019. And as our previous lease of various floors and parts thereof at 901 King West was coming to an end. The ability to lease 2 levels, 21 and 20, of the Well, a LEED Platinum certified building, would give us the opportunity to regroup our previously scattered teams and become a home that aligned with our sustainability goals. Designed at the height of COVID-19 pandemic, the creation of our new studio was an exercise in flexible post-pandemic workplace while championing innovations in sustainability. We spent time as an office thinking about how we wanted to work. The design philosophy had the following in mind: wellness, people-centered design with wellness at the core; sustainability, embed smart and creative design thinking by upcycling and act as an exemplar of sustainability; inclusivity, the physical environment will be fully inclusive and wired for accessible technology; innovative, we'll embrace innovative thinking and sustainability by making the studio a living lab; and it will be agile and resilient that supports hybrid working and will be flexible to adapt to an unknown working landscape. The gross floor area of our studio is 3,075 meters squared. We have 2 floors on 21 and 20, connected by a central stair highlighted in orange. On the 21st floor is our reception, and you can see on the 21st floor we have various neighborhoods, working neighborhoods that are home to our various design teams throughout the office. We also have 2 wellness areas. On the south end is our Oasis, and on the north end is our wellness room. And we have nourish areas on both the 21st and 20th floors. In light blue, our open annex and community space on the 20th floor. And last but not least, our materials and fabrication lab at the north end. Our design team and sustainability teams collaborated to establish and then follow 3 strategies for a successful and responsible new workplace. The vision had 3 elements: health and well-being, whole life carbon, and performance. We set parameters for health and well-being so that our staff would not be exposed to harmful substances. We would monitor indoor air quality and maximize biophilic effects of materials and contribute to a productive and active culture. To ensure our work environment is free from harmful substance and accessing the materials used in the office, the Living Building Challenge LBC Red List was referenced. In referencing the substances list, several materials were switched out for alternative Red List free specifications. Internal environmental conditions are monitored with a number of IAQ monitors placed around the office. We've implemented a cost-effective brand called AirThings, which link via Wi-Fi to a live dashboard. They are aligned with the requirements of WELL standard. Our design and material selection focus around incorporating nature in the form of plants, natural materials, and natural shapes. We found that whole life carbon analysis and design was in its infancy only a few years ago, but committed to use circular economy principles for our move and embed them into the design, construction details, and operation of our space. The tools we used to analyze were one-click LCA, the EC3 toolkit, circular economy principles, and a well-developed Revit model for material takeoffs. Through research, we established some baselines and set the industry baseline at 200 kilograms of CO2 per meter squared. The stretch was set at 150 kilograms CO2 per meter squared and determined that an industry-leading project could be set at 136 kilograms of CO2 per meter squared. Being designed in the midst of COVID and our knowledge of supply chain issues at the time, we decided it was reasonable to target between the stretch and industry leading. Last but not least, we set specific verifiable targets so that our studio could be an exemplar of innovative design for us to learn from and evolve. Although we weren't seeking LEED certification, we did use the scorecard to track progress. We also tracked and targeted WELL certification and made sure that our employees are satisfied with the operational performance of our space. The driving pillar of the studio design was to embed smart and creative design in the strategies we undertook to reduce carbon. The first strategy was to build less. Our concrete columns are left exposed, our raised access floors are celebrated, and flooring applied selectively, and our ceilings are meticulously coordinated to let the conduit layer on top of the exposed concrete ceilings without offense. We celebrated design moments in the office and focused on those to provide destinations in the office. We also built light. Our back alley, aptly named as a homage to alleys of Toronto, and like an alley is layered with years of graffiti, our back alley is a pinup space and crit space with layers of design iterations and studies. This space is one example of building less. The acoustic ceiling tiles were strategically removed in a purposeful way to create a random deconstructed grid, a creative way of using less of a given material to do the same work. A large contributor to our carbon reduction was to think of upcycling the inventory that we had at our previous office. This was both an opportunity to create a resilient and sustainable workplace and a creative way to pay homage to the evolution and history of our studio by upcycling materials, products, and furnishings. This inventory was large: case goods, light fixtures, equipment, appliances, desks, chairs, and everything in between. We challenged ourselves to reduce as much carbon as we could. Our materials and quantities were analyzed through one-click LCA, and we underwent a robust analysis of the specifications and their associated EPDs. We conducted an embodied carbon studio through one-click LCA during design development to test the material selections, as well as at construction completion to verify the design. Conducting the study early in the design process allowed us to pivot the design to negotiate the carbon targets that we're after and nip the offenders early in the design process. This graph represents the mass of each design element category. You can see that furniture is the largest by weight, followed by interior partitions, ceilings, floorings, and the central stair. The carbon content and global warming potential for the design element categories are then assigned, as can be seen in the right-hand side graphic. You will notice that furniture becomes an even larger portion of the overall pie when the GWP of partitions goes down due to its associated carbon intensity. This type of breakdown is typical of interiors projects. It's also important to note that this is a representation of the studio with all new furniture. This bubble diagram is a graphic depiction of carbon content by category and a further breakdown of material categories. Again, furniture is the largest, but other categories have now grown in proportion to the carbon intensity, such as steel from our staircase, HVAC, which is already laid out in an efficient manner in the raised access floor, so we weren't likely to reduce carbon there, and carpet, then metals and gypsum. Let's take a minute to just focus in on the furniture. Breaking down furniture further, lockers and desks were the largest. An important carbon intervention is the first principle of circularity, reuse. We assessed which of the categories we could rely on to reuse from our previous office, those of which are circled here. Two options were assessed based on this. What would be the reduction if 50% of the furniture was reused, and what would be the effects if 100% were reused? The results suggested a 2 to 5 reduction in carbon. Chairs were the largest carbon contributors that we could rely on for reuse. All of our chairs were used for our new office. We also looked into options for carbon neutral products in the case that any needed to be replaced. Plan B was to purchase Kielhauer's carbon neutral swerve chair. When we went back and looked at the steel within the project and how we could reduce steel as a carbon intensive material, we looked at the components of the stairs and how we could mitigate some of the carbon. A wood alternative is better, but this needs to be OBC compliant. But if the stair was changed, it would have equated to a significant 7% decrease in carbon. Carpet was another big offender in the project. We had specified carpets for floor covering in all of our working neighborhoods due to its acoustical properties. In working with one manufacturer with an aggressive sustainability platform, we were able to choose carpets where we had net that we had and embed a net carbon negative backing. We then pushed all of our carpet specifications on the project to follow suit. This resulted in a 2% decrease in carbon. We looked at our wall covering suppliers about replacing the backing to less carbon intensive materials, and where we could, replacing wall covering with paint. This resulted in a 2% decrease in carbon. The last significant specification substitution was to replace LVT with linoleum. This reduced carbon by 1%. It's also better for our health as well. In the waterfall graphic, the baseline is on the left, then conservation interventions were quantified. Replace Corian with porcelain countertops, replace LVT with linoleum, expect that a 30% furniture would be recycled. Vinyl wall coverings were replaced with paint and using the Sequest GB backing on our carpets. A further reduction would be seen if 60% furniture was recycled and the stair materials were changed. The LCA was rerun at the end of the project to verify. We can see the final embodied carbon was verified at 166 kilograms of carbon per meter squared. The lessons learned were to resource, reuse, material selection, designing out waste, designing in layers, designing for disassembly, designing for adaptability, circular business models, and circular economy enablers. We also just wanted to quickly point out that we're very proud that our studio has achieved WELL Platinum certification just this month. A review of the WELL certification project directory revealed that we are one of only 9 Platinum certified projects in Canada, are the first architecture and design studio who's Platinum certified in Canada, and it's our first BDP project to receive WELL certification. That brings us to the end of the presentation, but really it's only the beginning of the conversation. Please do not hesitate to reach out to myself or Aman from our internal sustainability team to chat further. Thank you so much.
Thank you, Jessica. Thank you, everybody, all the presenters, for giving us an insight further into your projects and what made them so great and won in your categories. I had a quick question. I don't see any questions in the chat, so feel free to throw some in there for any of the presenters. But I did have a question for Melinda and Rick, and potentially Deirdre. She could touch on it. But my question was about scaling up and the ability to scale up either the projects or the systems. And how big you've gone, I guess, is the question.
Yeah, so we have been scaling up since the beginning, and we are at a point now where we are actively putting together plans to do a significant bump in our scaling up. So we started doing mostly single family homes, and since then we still do single family homes, but we also have done sixplexes, and we are currently in design with a community partner for a 72 unit building. So moving into also the mid-rise residential sector. We can do it's interesting. We can do about 20 single family homes or about 100 units of affordable housing in a multi-unit building per year currently, which is when I did the calculations myself, I was a bit surprised because even though I know it's much more efficient. So that's a real opportunity for us to scale up the development of housing. And we are currently looking we have 2 phases. We have a renovation plan for our existing space and some equipment purchases additional. We have a CNC saw and some automation equipment, but we are looking to add to our equipment for further automation and to increase our scale there within our existing space with some fixing it up. But also we are looking for a secondary location in our community to potentially have a second facility where we can significantly scale up our manufacturing, possibly with some robotics. as well. So looking for
Have you
partners
been,
and people who want to work on that.
yeah. Have you been approached for any commercial projects or is it all residential that you're?
We have, there's commercial component to one of our projects. We've mostly been in the residential sector. I don't know, Rick, if you want to, I mean, we are on the commercial side now of working with more developers as opposed to our first projects where often the client who was going to live in the home would approach us and connect us with their builder or but now the builders are bringing us to their clients and the developers are bringing us to their builders. So from that way of doing things, but I don't know, Rick, if you wanted to answer that question as well.
Yeah, we're also looking at with two developers, the possibility of doing a hotel, so a multi-story. That would probably be for that. It would be a mix of CLT and our panels. So the structural elements would be CLT. The floor is probably CLT, and all of the wrap would be the panels. And then those buildings could go very quickly as well.
Yeah. Good. Yeah, it'll be good to see that scaled up, I think.
All we need
Yeah,
is
our
where's my money? All we need is
Yeah,
money.
yeah,
yeah.
yeah. Fair.
Anywhere from $1 to $30 million to
Yeah.
just, do any of those plans if anybody's on the
Yeah.
calls looking for investment. The model though, so right now we are shipping to Northwest Territories, to Maine, to the US, and the ideal model that we envision and would like to see develop though is having local manufacturing in people's communities. So we want to serve it. It makes more sense if still even when we ship a long distance, the carbon is still less than the typical building options and the performances in there. But um, we would like to see this type of manufacturing just, dispersed across our communities. And we are working with a First Nations led group in Kirkland Lake, and they are currently building a factory to serve their own community to do similar panels up there as well. So that is part of our
Nice.
objective as well, is to support other people developing this capacity in their communities.
Yeah. Yeah. Sounds like a really good business model. Um, Deirdre, have you looked at scalability and how far you can scale up? Yeah.
Yeah. Strawworks is happy and healthy on a small scale. I'm on the tools. I like that. I have 1 to 4 employees at any one time. But when we have been approached, we were approached by the town of Norwood to build their health center. And so I think about these things. And for something like that, we would scale up probably with straw bale panels, reach out to probably new frameworks, and we would work with general contractors. So we would scale up in that capacity for that specific project, and then probably scale back down. Um, we're builders, we're carpenters, so we like to frame buildings. We like to get the roof on and then install the straw. So, and our cost of framing and bales is still less than new frameworks for their panels.
Mhm.
So there's no real advantage for us to switch to panels right now, unless that type of a project came our way. And I do like big projects, so I would be interested in that.
Yeah.
Well, maybe we can
Yeah,
put, we
yeah.
did do some early models of built ups of straw bale panels and dense packing with chop straw and all kinds of things like that in our factory. We ended up going with dense packed cellulose because of the CSA certification required and things like that. But if you ever want to play with some straw bale panels, and give us a shout. I'm happy to
Yeah,
see what we can do.
yeah.
It'll be fun.
Winter project.
Yeah.
Well, we're 1 minute away from our time. I thank you all again for your time and for your really great projects. It's been really good getting to know you and getting to know the projects that you brought to us and that won. So keep up the good work, and I'm sure we'll see you again.
Sure.
Don't forget, we will have another Embodied Carbon Awards in November. So if you have more projects you want to submit, there are no limitations. So that should be coming out, I think, within the next month, the call for submissions for that. And then the dates will be finalized for that as well. So thank you all, and thanks everybody for joining us, and we'll see you at the next one.
Thanks so much.
Have a good day.
Everybody,
Take care.
You-
Bye.
have a good day.